This is a new topic, which the block 3, which is you will study about the waves, types of waves, properties of the water waves, and properties of sound waves and light waves. So first thing, definition of the wave. What is wave? It's also a mode of energy transfer. Like example, the way energy can transfer from one place to another, that's also known as, this is one way by which energy can transfer, or mode of energy transfer. So the first thing you should understand, there are two types of waves. One is called transverse wave, another one is longitudinal wave. What is the difference between the two types of waves? The difference is only the motion of the particle, like how we can distinguish whether it's a transverse wave or a longitudinal wave. So we can distinguish by the motion of particles. Because in a transverse wave, the particles are moving in a different manner as compared to longitudinal wave. So first, what is a transverse wave? Example, if you take a string or a wire and you're moving the wire up and down, you take a string and a wire and you're moving this wire up and down. For example, another person is holding this point. So another person at position A and he's holding this position, the wire or the string at point A. So person at A can feel the force or can feel the energy. So what is the direction of energy transfer? In which direction energy transfer? So direction of energy transfer in this example is towards right hand side. But what is the direction of the particles? Look, you have a string or a wire. You are holding position A and your friend is holding position B. You start to vibrate or move this wire up and down. So when you move this wire up and down, this is a pattern which you will see. So what will happen when wave reach position B? The person who's holding the point B or position B, he will feel the force or feel the energy. So when a person at position B feels the force or feel the energy, so direction of energy is same as the direction of the wave. So what is the direction of the wave here? The direction of the wave is from left to right hand side. Direction of the wave means direction in which the energy transfer. But what about the direction of the particles? How the particles are moving? Like example, if there is particle 1, this particle will move up. If there was particle 2, this will move down. If there is particle 3, that will move up. So the particles are moving up and down, but the wave, the direction of the wave is towards right hand side. So when the direction of the wave and the direction of the particles or the motion of the particle is 90 degree or perpendicular, you can see there's an angle 90 degree between the direction of the wave and the particle. So when the angle between the particle and the wave is 90 degree, this kind of wave is known as transverse wave. And it is easy to remember this term transverse. As you can see, if I write letter T, so when I'm writing letter T, what are the angles here? 90. So it's easy to remember. Transverse means when the particles and the direction of the wave are 90 degree or perpendicular to each other. So if this is a wave, you can see what is the direction of the particle. The particles are moving up and down. This particle is moving up and down. But what is the direction of the wave? The wave actually travels from one place to another. But the particles moving up and down or vibrating up and down, what we call this kind of a wave, there's a 90-degree. How you can see there's, look, what is a 90-degree? The angle between the wave. What's the direction of the wave? The wave is towards right hand side. What is the direction of the particle? The movement of the particle or motion of the particle, they are moving up and down. So direction of the wave and the direction of the particle are 90-degree. And what we call this kind of wave, we call this as a transverse wave. Is it clear? You can see like the particle at this point. See, this particle is moving. If you focus on any one of the particle, you will see it's moving up and down. Any doubt in this part? The transverse wave? The motion of the particle and the direction of the wave are 90-degree to each other. Then another type of a wave is known as, and these are some examples of a transverse wave. The examples of a transverse wave, like example, radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-ray, gamma. These rays, you have to learn the examples. These rays are all transverse in nature. Like their vibration is 90-degree to the direction of wave. So when the wave travel from one point to another, the direction of the particle is always 90-degree. For this transverse wave, we define certain terminologies. What are the terms we define for this? As you see, the highest point, this is a transverse wave. So certain points we define for this transverse wave. This highest point is known as the crest. And the lowest point is known as the trough. The distance between the two successive crests, when two crests are separated by some distance, that distance is known as length of the wave or wavelength. This distance is known as wavelength or length of the wave. Same thing, the distance between the two successive troughs, the distance between the two successive troughs is also known as wavelength. The distance from the center position to the extreme position, this vertical distance or the height of the wave, that is known as amplitude. Same way, distance from mean position to the extreme position, That's also known as amplitude. So for a transverse wave, these are the terms which we use to explain the transverse wave. The highest position are known as a crest. The lowest position are known as a trough. The distance between the two successive crests known as a wavelength. Two successive troughs also known as wavelength. The distance from mean position to extreme position is known as amplitude. And length of the one wave, like if we can also take the length of one wave like one complete crest and one complete trough. This length is also known as wavelength. So wavelength is a distance between two successive crests, two successive troughs, or the length of one complete wave is also known as wavelength. So how many wavelengths? Example, if I say for this figure, how many wavelengths are there in this figure? How many wavelengths? Look, if you start from this position, so one crest and one trough, that's one wavelength. Then another one crest and one trough, that's another one second wavelength. And that's only half. So this is one wavelength. And how we represent wavelength? Wavelength is denoted by a Greek alphabet lambda. So this one wavelength, one lambda, and this is only half of the wavelength, so 0.5 lambda. So how many wavelengths are there total? 2.5 lambda. Is it clear why it's 2.5? It's not completely 3, because if it was 3, then the last wave should be complete like this. Then it will make 3 wavelengths. But this is not 3. This is actually 2.5 wavelengths. And the unit of the wavelength is, SI unit is meter. And it is, wavelength is denoted by a Greek alphabet lambda. So one wavelength, second, and then 2.5. How many wavelengths are there in this example? How many wavelengths in this example? In this one, we have 2 complete wavelengths. You can see one crest, one trough, that's one wavelength. And then there's the second wavelength. How many wavelengths are there in this picture? It's a 3D. How many wavelengths you can see? Like this is 1, 2, 3. So amplitude is the distance from mean position to extreme position. where wavelength is a distance between the two successive crests or troughs, or distance or length of one wave. How many wavelengths are there in this picture, starting from this point A? How many wavelengths are there? Approximately, it's not exactly, it's approximately. Yeah, this is approximately 3 wavelengths. So 1, 2, 3 wavelengths. What is the label for position A? What we call this point A? Point B? Yeah, that's right. And what we call a distance from center position of a wave to the extreme position, this distance C, what we call? Yeah, that's right, amplitude. And the distance between the two successive crests, yeah, that's right, it's known as a wavelength. So these are the things related to transverse wave. You should know the labels, and the direction of the vibration of the particle is 90 degree or perpendicular to direction of the wave.